Okay, this is a lecture on week 10. So we still continue with the differentiation. Now is if you refer to my notes, that is on the differentiation. There is a implicit differentiation of 4.5. It's an implicit differentiation. Now, if we have look at one example here. So, if we have y is equal to x raised to 2 minus by 2x minus by 6, and then the other one we have y squared minus by x squared equal to 2y plus by 7. Now, if you refer to these two equations, so here we have y here is the y here is written as a this is can be written as a explicit. This is a explicit. In other words, this is explicit in terms of x. So y is explicit in terms of x, and this is y explicit in terms of x. But this case, y squared minus by x squared is equal to 2y plus by 7. So we have two relationships here, y and x. And y and y. This is equal to, this can be defined as implicity by a relationship between x and y. So we have y and y in the same equation, but in this case we have y and x. Here we have y and y and x and y. Okay? So this is known as a implicity by relation between x and y. So today I want to solve the equation here, the differentiation here. So let's say we solve the explicit differentiation, and let's say I want to find y prime here. So let's say here is a, this b. So a, I want to find a y prime, or I want to find dy dx. So dy dx, or let's say I want to find this as a y prime. So for a, so dy dx or y prime is, so dy dx equal to 2x. Then you differentiate of this one, this function here. Differentiation of x with respect to x is d dx of x minus by 2 d dx of x minus by 0. The differentiation of constant is equal to 0. And here, this can be written as 2x dx minus by 2 dx minus by 0. Then we have 2x minus by 2 minus by 0. So this is a final answer for the first one, y prime. Okay. Now, then look at question B. Y squared minus by x squared is equal to 2y plus by 7. I want to find the y prime or dy dx. dy dx. So dy dx for this one. Now, if we integrate this function with respect to with respect to x, we get 2y d dx of y minus by 2x d dx of x equal to 2 d dx of y plus by the differentiation of constant is equal to 0, and this can be written as 2y dy dx minus by 2x dx equal to 2 dy dx plus by 0. Now, so here you can write as a 2y dy dx minus by 2x dx is equal to 1, okay, 1 equal to 2 dy dx plus by 0. Okay. So we have two common here, dy dx, common factor here, dy dx. So this can be written as 2y dy dx. So you bring to the left, you have minus 2 dy dx. So this one you bring to the right, you get plus 2x. So this will give you an answer of, okay, so the common factor here is a dy dx. So I have dy dx 2y minus by 2 is equal to 2x. So in other words, dy dx is equal to 2x over 2y minus by 2. So dy dx we defined just now is y prime. So in other words, y prime equal to 2x over 2y minus by 1. You simplify this equation, firm terms, and then the y prime equal to x over y minus by 1. This is how we solve the implicit differentiation. Now the next example, I have example 4.17. Example 4.17. Example 4.17. So I have yx plus 4 plus by x y raised 2 equal to 4. We want to find y prime or dy dx. So this refers to implicit differentiation because of we have a relationship between y and x here, y and x. So this is what we call the implicit differentiation. Now, so to solve this one, so we have two things here. This you can use a product rule. Use product rule, and this one also you can use a product rule to solve the differentiation here. Okay. So product rule say that if you want to solve this one, you can put this way. Product rule say that dy dx is if you have we refer to the product rule. Now the product rule say that if I have two functions here, let's say fx equal to fx gx, okay, there's two functions, y multiplied by x4, x raised 4. So here refer to y, and here is refer to x raised 4. And this one you can refer to x, and here is a fx, this one is a gx. So here is equal to y, fx is y, gx is 1. So if you apply this product rule, this equal to, so the differentiation of this one, or f prime x equal to fx g prime x, fx g prime x plus by gx f prime x. This is a product rule. So for this case, we use a product rule. So your fx is y. So we need to say the differentiation here is your fx is y. So I put here as a y. So I want to find the differentiation here. So fx is y. So I put y here. Now g prime x is the differentiation of x raised 4. The differentiation of x raised 4 is 4x raised 3 d dx of x, okay, x plus by gx is x raised 4, and then f prime x is the differentiation of y, so d dx of y. This is we solve the equation here. Okay, we solve the first part here. Okay. Plus by, now if you solve this one, your fx is x. By this formula, fx is x, and then your gx is y squared. So g prime x is 2y, then d dx of y, then plus by gx is y squared, multiplied by f prime x. F prime x is the differentiation of x, or d dx of x, equal to, now the differentiation of 4 is equal to, the differentiation of constant is equal to 0. Okay, so if I solve here, I will get y multiplied by 4 is 4y x raised 3, dx is 1, plus by x raised 4, d dxy is dy, x raised 4 dy dx plus by x multiplied by 2y is 2xy, d dxy is dy dx, plus by y squared, dx is equal to 1, here is equal to 0. So I can group dy dx together, this one I group together. Okay. So this thing I can write like this. So just put like this. So this one I bring to the left, to the right. This thing I bring to the right, and this thing I bring to the right. So I have x raised 4 dy dx plus by 2xy dy dx equal to this thing I bring to the right. We get negative 4yx raised 3, and this thing also I bring to the left, minus by y squared. So the common factor here is dy dx. Here you can write like this: dy dx multiplied by x raised 4 plus by 2xy equal to negative 4y x raised 3 minus by y squared. So in other words, then this can be written as, so dy dx is equal to negative 4y x raised 3 minus by y raised 2 over x raised 4 plus by 2xy. This is how we solve the section of example 4.17. Now, given that 3x raised 4 plus 5y raised 2 minus by 2y equal to 4. I want to find y prime or dy dx. So this refers to implicit differentiation. So multiplied by 4x raised 3 d dx of x plus by 5 multiplied by 2 y raised 1 d dx of y minus by 2 d dx of y equal to the differentiation of 0 is equal to 4 is equal to 0. Here is 3 multiplied by 4 is 12, 12x raised 3 and dx plus by 10y dy dx minus by 2 dy dx equal to 0. So this can be written as 12x raised 3 dx is equal to 1 plus by 10y dy dx minus by 2 dy dx equal to 0. So I bring this thing to the left, to the right, I get 10y dy dx minus by 2 dy dx equal to negative 12x raised 3. So the common factor here is dy dx, so I have dy dx multiplied by 10y minus by 2 is equal to negative 12x raised 3. In other words, dy dx is equal to negative 12x raised 3 over 10y minus by 2. So these are final answer. or you can simplify this thing as a, you can simplify this thing as a, or you can simplify this thing as a, so I have 12 negative 12x raised 3 over, I can put here as a 2, 5y minus by 1, so negative 12 divided by 2 is negative 6, x raised 3 over 5y minus by 1. So you can do this way. Okay? This is an implicit differentiation. And that's all for differentiation. So there is a few exercises here on differentiation. I want you to form a group consists of 6 students, a group of 6 students, a group of 6 students. Then solve this problem. Okay, so assignment 1. So this is a group assignment. Assignment 1 group assignment 1. So the question is, I have a few questions here. So solve, find, this is assignment 1, find number 1. So find f prime x or dy dx if A, I have fx equal to 4 over 5, B, fx equal to 3x plus 5, C, fx is equal to 5 raised 2, then D, fx equal to 3x raised 2 multiplied by 3x minus by 2. This you can use a product rule. You can use a product rule here, or you can expand this bracket. You can use product rule, or you can expand this bracket. E fx equal to 2x minus 5 over x plus by 1. This you can use a equation rule. Okay? Equation rule. Use equation rule. And last one, f is fx equal to 4x squared plus 1 raised 3. Okay, so this is question 1. Then question number 2. Question number 2. Find f prime or find y prime if A, I have y is equal to x raised 3 plus 5, and B, y is equal to square root of x plus by 5. Okay. Now the next one is assignment 2. This is also a group assignment. Assignment 2. Assignment 2. I have here assignment 2. Assignment 2. Group assignment 2. So assignment 2. So find the y prime on number 1. Find y prime if x squared plus y squared is equal to 25. These are implicit differentiation. Okay. And number 2, find y prime if x raised 3 plus by y raised 3 equal to 6xy. 6xy. This is also implicit differentiation. Number 3, okay, also find y prime if sine x plus y equal to y squared cos x. This is also implicit differentiation. And then 4, find y prime if y is equal to x raised 3 plus by x minus by 2 over x raised 3 plus by 6. You can use a quotient rule. 4. Then I have the other one is number 5. Find y prime if y is equal to 1 over root of 3 x raised 2 plus by 2x plus by 1. And the last one, number 6, find y prime if y is equal to square root of secant x raised 3. Secant x raised 3. So there are the 2 assignments here. So form a group consists of 6 students. 6 students. Please email to me or send to my guru. So you can upload in my guru. You upload the assignments on before 3rd of July. 3rd of July. Okay, before 11 July. 11 of July. Before 11 of July. July 2020. For 11 July 2020. Put in my group, okay? Maybe a 2 assignment here, a group assignment. Okay, we have finished differentiation, okay? Now I want to go to integration. So the next topic is integration. Next topic is integration. integration. Okay, the fundamental theorem of integration is let f continuous on AB for f on AB if fx equal to the integration symbol s here, integration AB, the lower limit and upper limit fx dx. This is a basic or a fundamental. Now, this is equal to, the derivative here is equal to, this one is equal to, so you can substitute here is equal to, or you can put here like this. These are fx, capital Fx, AB equal to FB minus by capital FA. Okay. Now, this is the definition of integration, and the basic rule of integration is if I have fx, supposed by fx here, fx. Let's say I have fx x raised a. So the integration of this one, is of capital Fx. The integration capital Fx is equal to x a plus 1 over a plus 1. So a cannot be equal to 1. Okay. Now, if I have is trigonometry, the sine x, the integration of sine x is equal to negative cos x. Now, the integration of cos x, integration cos x is equal to sine x, and secant square x is a tangent x. Integration of secant square is tangent x. Then the integration of cosecant c square x is equal to negative cotangent x. Then secant x tangent x, the integration of secant x tangent x is equal to secant x. The integration of, if I have a function of c cosecant x multiplied by cotangent x, this is equal to negative cosecant x. Integration on this part. And if I have the function of x raised negative 1 or 1 over x, the integration of this one is the exponential log x. And the integration of exponent, raised x is equal to the integration of, let's say here is fx, so the integration of this one is also exponent x. This is a basic concept of basic fundamental theorem of integral. Okay, we continue with our integrations. So please refer to example 5.2. Example 5.2, the integrations. Let's say I want to integrate this function. I want to integrate it from, the limit here is from -1 to 5, 1 plus by 3x dx. I want to integrate this function. So the integration of a constant here, 1 is 1x or x, 1x plus by 3 is a coefficient. By differentiation, integration of x is x raised 1 equal to x raised 1 plus 1 over 1 plus 1. So I have here x raised 2 over 2. Then substitute for -1 and 5. So this is equal to, when I substitute x is equal to 5, so 1 multiplied by x is 1 multiplied by x is x. So here is 5 plus by 3 multiplied by 5 raised 2 over 2. Then minus by, you substitute for -1 plus by 3 -1 raised 2 over 2. So this can be written as 5 plus by 3 multiplied by 25 is 75 over 2 minus by -1 plus by 3 multiplied by -1 square is 1, 3 multiplied by 1 is 3 over 2. So this can be written as 5 plus by 75 over 2 plus by 1 minus by 3 over 2. So here is 6 plus by 72 over 2. So 72 over 2 is 36. So 6 plus by 36 equal to 42. This is the answer for A. Now B, I want to find the integration of the limit here is 1 to 2 x raised 3. So x raised 3 dx. Now by definition, the integration of x raised a equal to integration of x raised a is equal to x a plus 1 over a plus 1. So if I have x raised 3 is equal to x raised 3 plus 1 over 3 plus 1, then substitute for 1 and 2. So here we have x raised 4 over 4, substitute for 1 and 2. So I have x raised 2 raised 4 over 4 minus by 1 raised 2, 1 raised 4 over 4. So 2 raised 4 is equal to 16. Okay. 2 to the power of 4. 2 to the power of 4 is 16. 16 over 4 minus by 1 over 4 is equal to 15 over 4. So this is our final answer. Now look at example 5.3. Example 5.3. So I want to find the integration of example 5.3. I want to find the integration of from 3 to 4. Here is from 3 to 4. Is from 1 to 4. Then I want to find 2 square root of x dx. So since 2 here is a coefficient here, so you can just leave like that. You can put this way: 2 multiplied by 1 over 4 square root of x dx. So square root of x is equal to, here is 2, 1, 4. Square root of x is x raised half dx. So by definition, this is equal to, the integration here is equal to x raised half plus by 1 over half plus 1. Then substitute for 1 and 4. So we get here 2x raised 3 over 2 over 3 over 2. Then substitute for 1 and 4. So x here is equal to 2 multiplied by, so first we substitute 4. 4 raised 3 over 2 over 3 over 2. Then minus by, then you minus by 1 raised 3 over 2 over 3 over 2. So this is equal to 4 raised 3 over 2 is equal to 8. 8 over 3 over 2 minus by 1 over 3 over 2. So equal to 2 multiplied by 7 over 3 over 2. Okay. So 7 over 3 over 2 is equal to 2 multiplied by 14 over 3, 58 over 3. Now, the other part is I want to differentiate, integrate this function. The limit here b, the limit is from 0 to 1. I want to integrate x raised 1.5 minus by x raised 0.5 dx. So this can be written as, so you can put this way: integration of 0 and 1. Okay, the integration of x raised 1.5 is, by definition, is x raised 1.5 plus 1 over 1.5 plus 1 minus by x raised 0.5 plus 1 over 0.5 plus 1. So substitute for 0 and 1, 1 and 0, 0, 1. Then we get 1 raised 1.5 plus 1 is 2.5 over 2.5 minus by, so substitute for 1 here, I have 1 raised 0.5 plus 1 over 1.5. Then minus by, you substitute for 0. 0 raised 1.5 plus 1 over 2.5 minus by 0 power 0.5 plus 1 over 1.5. So this part is equal to 0. This thing is equal to 0. Now here is 1 over 2.5 minus by 1 over 1.5. So this will give an answer of 1 over 2.5 is 0.4 minus by 1 over 1.5, 0.66. So here is, if you write here is 1 over 2.5 is 2.5 is 5 over 2, 1 over 5 over 2 minus by 1 over 3 over 2. So this can be written as 2 over 5 minus by 2 over 3. So 2 over 5 minus by 2 over 3 is equal to 6 minus by 10 over 15 or negative 4 over 15. So this is one answer. Okay? Then this is the basic integration. So then we go to the next part is 5.3. 5.3 is indefinite integral. So for the indefinite integral, we do not specify the limits. So for example, if I integrate this one, integration of without a limit here, I do not put a limit here, fx and dx, this is equal to, answer is fx plus by c, and where c is a constant, where c is a constant, Okay. Now let's say I have here the integration of x raised n dx. So here is equal to x by differentiation n plus 1 over n plus 1, then you have to add up by c. Okay. Then if I want to integrate 2x dx, so here is this equal to 2x raised 2 over 2 plus c, and here is equal to x raised 2 plus by c. Because of here you can find c. So to integrate this one, okay. So by definition here is 6x 2 plus 1 is equal to 3 over 3 minus by 8x 1 plus 1 2 over 2 plus by 3x plus by c. So this is equal to 2x raised 3 minus by 4x raised 2 plus by 3x plus by c. Now if I have this function, let's say I want to integrate x raised half or square root of x, this is equal to x raised half dx is equal to x raised half plus by 1 is 3 over 2 over 3 over 2 plus by c. Over 3 over 2 is multiplied by 2 over 3. 2 over 3 x raised 3 over 2 plus by c. Okay. And the last one. Now if I want to integrate exponents raised x dx. So exponent raised x is the integration by definition. The integration of exponent raised x is exponent raised x plus by c. Okay, I think that's all for today. So instead of in addition to the assignment I give you just now, there will be a test on 11th of July. Okay? So I will give you a test on 11th July. Okay, there will be a test on SMU 0023. SMU0023. The test will be held on 11 July 2020 on Saturday. So the time is from 9 p.m. to 11 p.m. This is known as an at-home test. It's an open book test. The topic covered is open book test. So the topic covered is pre-calculus, functions, domain and range, pre-statistics, okay? And the third one is limits and functions, limits and functions. Then the third topic is differentiation. So this is a topic covered. Okay. So the test question will be upload. I will upload the test questions on my group. Upload on my group. Then answer the questions, submit the questions, submit the answer also to my group. The answer to my group. Okay. So you have to submit the answer before 11:55 p.m. on July. So I will upload the test questions at 9 p.m. So answer the questions, then submit the question before 11:55 p.m. on Saturday. Thank you very much.